The last proof of Euclid Book 4, which is proposition number 16, is a monster, okay? First of all, you have to draw an equal angular and equilateral pentagon. How are you going to do this? Well, the first thing you're going to do is you're going to draw a triangle, and when you draw this triangle, the bottom two angles have to be 72 degrees, and the top one has to be 36 degrees. And you'll use a tangent line, much like this one right here, to make, this is the tangent line to this circle, and you're going to use that to make your triangle. Then you're going to bisect the angles, this one here and this one here, and when you do, you're going to have these 2 points right here, and when you draw every one of these lines, like we showed you in a previous proof, you will have an equilateral and equal angular pentagon. Then you have to draw an equilateral triangle on top of the equal angular and equilateral pentagon. Now, if you go off to the side and draw an equilateral pentagon, not pentagon, but equilateral triangle, and then you duplicate the angles of that triangle in here, you're going to find out that each one of these angles, here, here, and here, they're all going to be 60 degrees. That's right. Anytime you draw an equilateral triangle, you're going to have three angles that are 60 degrees apiece. Okay, so you use this tangent line right here. You're going to draw your equilateral triangle, and it's not only going to be equilateral, it's going to be equal angular as well. So far, so good. Now, here comes the proof. You've drawn a circle. Inside the circle, you have inscribed an equilateral and equal angular pentagon and an equilateral and equal angular triangle. Okay. Now, when you draw this 15 figure, what you're going to do is you're going to draw a 15-sided polygon. Okay, that's what the proof is all about. You're going to draw a 15-sided polygon. Each one of the sides is going to be exactly the same length. Now, how do you make sure of that? Well, first of all, you're going to look at circumference ABC. Here's circumference ABC. Now, circumference ABC is exactly 1/3 of the circle. Okay, from C to D is 1/3, from C to A here is 1/3, and from A to D is another 1/3. So we've divided this circle into 3 equal parts. Okay? So that means that 5 of the 15 sides of this polygon are going to fit between A, B, and C. Okay? Between A, B, and C is going to be 5 of the 15 sides. Okay? Now, between A and B, we of course have divided this circle up into 5 equal parts. A, B here, B, and whatever this point is here, and so on and so forth. Okay? So you're going to find 3 of the 15 sides between A and B. You're also going to find them between B and this point right here. Okay, so there's one side, there's 2 sides, there's 3 sides. Alright. Between B and C, you're going to find 2 of the 15 sides. So, if between B and C, you're going to find 2 of the 15 sides of this polygon, what you're going to do is you're going to bisect circumference BC. And you're going to use Euclid Book 3, proposition number 30 to do this. Once you do, you find point E, and then you start joining your lines. B to E, E to C, both of these will be the same length, and C to this point here will be the same length. And you do this all the way around the circle, and kabang and kaboom, you have now drawn yourself a 15-sided polygon, and all sides are going to be the same size. Alright, I will start Euclid Book 5 in a few days. When I do, I'm going to teach you the Greek letter sigma. Okay? Because what we're going to teach in Euclid Book 5 will lead to the Greek letter sigma. Alright, I will tell you more in a future video, so stay tuned.